Herzberger, Max, American theoretical physicist. Berlin, Germany, March 7, 1899. Herzberger studied at the University of Berlin as well mathematics and physics as philosophy. He got his PhD magna cum laude 1923 with a dissertation on hypercomplex numbers. He was always interested in the history of his studies as well as in the interrelations of different disciplines. Devoting himself first to problems of geometrical optics, he found in the then neglected work of W.R. Hamilton, reducing geometrical optics to a problem of variation calculus, a powerful tool for a systematic study. Tracing first a single ray, then a manifold end of rays through an optical system, he used from 1937 the spot diagram method, the tracing of all well-defined systems of rays through the optical system, bracket closed, to have a graphical equivalent for the light distribution in an optical image. He studied many kinds of image formations and found for a system with symmetry plane on axis that the intersection of rays with the symmetry plane, the dia points, gave insight into the structure of the image and led to an image theory for finite image error, considering the symmetry of the image formation. The fact that neither object nor image can be a mathematical point due to their graininess led to a diffraction theory based on the restriction of the light flux, the only invariant for a manifold of rays, as an integer multiple of an elementary light flux. Period. Herzberger considered this the application of the theory of quantum mechanics to optics. For more than 20 years, he investigated the wavelength operations, color operations. He found for the visible region that the dispersion of a transparent substance is given by 4 data, and with such a dispersion formula, substances can be found for which color could be corrected by 4 wavelengths and subsequently for all intermediate wavelengths. Herzberger was, with 7 years of age, freed from attending mathematical classes, only participating in the semi-annual tests. He graduated from high school in 1917 with honors, being in the German army for 2 years. Period. He visited the University of Berlin, Germany from 1919 to 1922, getting his PhD magna cum laude March 1923. He decided to enter the field of optics. He was 1925 to 28 with A. Lights as head of the calculation bureau, 1928 to 35 with Carl Zeiss as assistant of Professor Straubel and working with him on diffraction, and with H. Bilgerhold on geometrical optics. Publishing in 1931 the book Strahlenoptik, J. Springer, which contains the solution of classical and new problems starting from the technical tools of W.R. Hamilton. 1931 he was habilitated at the University of Jena a habilitation accepted by the faculty but cancelled later by the National Socialist Minister President Frick. He left Germany in the fall of 1934 for Holland, where he taught at the University of Delft, being invited to lecture in all Dutch universities. He accepted a position at the Kodak Research Department, where Albert Einstein had written a recommendation. He worked with the research laboratory in Rochester 1935 to 65 as senior research assistant in charge of optical research. He got the Ives Medal of the Optical Society in 1962. Leaving Kodak in 1965, he taught at the Polytechnicum ETH up to 1971, then at the University of New Orleans up to 1978. These years were mainly filled with research of a general field theory. The principal ideas of this theory are: all the physical fields, mechanics, electrodynamics, optics, acoustics, thermodynamics, can be considered as the solution of the variation principle in space-time. Classical physics deals with points, rays, etc., that is, with objects which do not exist in reality. They can be considered as approximation if we are far enough from the object to neglect the deviations from it. Classical physics can be considered in space-time, where time is to be replaced by I times time. The four-dimensional space can be considered as a three-dimensional space changing in time, just like a motion picture changes the inserts in a plane in time. Minkowski, bracket close. An event is given by a quaternion, Hamilton, close. That means by a vector having three real and one imaginary coordinate. If we choose as fourth coordinate ICT, that means a multiple of IT, then we can show that all real velocity are smaller than c, and any secular quantity is the length of the vector, real in space and imaginary in time, and can be given as a square root of a quaternion, as a square root of the product of a quaternion which is conjugated complex quaternion. It is therefore always smaller than the length of the real part of the quaternion. The space is defined by a Lagrangian L, which is a function of position, of parameter, of velocity. Choosing as parameter S the arc length of the vector, leaving two lines out, we get a simplified variation problem. Position vector dA over ds, and the momentum vector P dl dx point I are the quantities of this theory. The choice of L permits to get the Euler equations of the motion of a point, P punct, and leave two lines out. This gives classical physics containing special relativity theory. Quantum theory is introduced if we consider as rays the bundle connecting elementary elements, see above. It is not necessary to introduce general relativity because gravitation theory is a special case of this attempt. Besides, leave the line out, is not the general variation problem. By considering L, the potential, and not the GIK as the given data, we can add potentials and therefore the problems, and we do not need interaction. The origin of the problem can be placed at will so to fit our problems best. Herzberger had received the Casey Morrison Prize of the New York Academy of Science in 1936, the Ives Medal of the American Optical Society in 1962, was appointed corresponding member of the Bavarian Academy of Science in 1959, honorary member of the German Optical Society in 1968, of the Rochester Optical Society in 1977, is member and fellow of the AAAS and of many optical and physical and mathematical societies in Germany, US, Switzerland. He wrote about 200 papers in optics, mathematics, and field theory. He wrote 2 books, Strahlenoptik Springer, Modern Geometrical Optics Interscience, Optical Articles im Handbook of Physics, Ulrich Condon, Physical and in McGraw-Hill, a finished memorial of Grassmann and Hamilton, and one on general field theory are ready to be published. He owes much thanks to Ishur A. Schmidt, C. Caratedori, Albert Einstein, and especially to the work of H. Grassmann and W. R. Hamilton. Biographical notes on his life are, among others, published in I thank you.